So for the first one, you're just going to punch this in the calculator. What's the sine of 20 degrees come out to be? What's that? 0.342. Okay. Cosine of 20 degrees, or 70 degrees. 0.342. Tangent of 25. What's that? 4663. Secant of 65. 1.103. 1.103?
Yeah, I get 1.2.
Yeah. How would we go about calculating that? Yep. Is it going to be cosine or sine?
Cosine.
So it'll be cosine 65 and then our reciprocal key. So cosine 65, close, reciprocal. It is 2.366. Cosecant of 10 degrees.
5.7588.
5.7588. Well, let's try it. What function do we use?
Sine.
Sine of 10, then our reciprocal key. What's that? On your, hold up your calculator once. There's an x -1 key there. So it is 5.7588. I'll come show you in a second, Kyle. So now for the tangent of, or cotangent of 50 degrees, what's that come out to be? 8391, okay, and that one would be found using the tangent of 50 degrees, then the reciprocal key. Okay. Everything we have done, every operation we have learned so far comes in pairs. If I have 5 plus 3, I get 8. If I want to take that back to 5, what do? I subtract 3. Addition and subtraction were what we called inverses. If I had 9 times 4, I get 36. What if I want to get back to the 9? What do? Divide by 4. Multiplication and division are inverses. If I have 8 to the power of 3 is 512. If I want to get back to 8, what do? The third root of 512 takes me back to 8. A root and a power are inverses. And what those are used for is if I have an equation like x plus 7 equals 11. The equation was put together by adding 7. To take it apart, we have to subtract 7. We have to do the inverse. Or if I had x squared equals 25, that equation was put together by squaring it. To take it apart, I have to use a square root, the inverse. So if I am told that the sine of an angle equals 0.338, if I want to figure out what that angle is, I can think of that, consider that my variable x if you want to. If I want to figure out what x is, right now x has had the sine done to it. To take it apart, I have to do the inverse. Well, the inverse sine on our calculators looks like that. A lot of you asked about that key. What is that sine -1 key? It is not, it cannot be used for cosecant because it's actually reversing the sine function. So the sine -1 and the sine would cancel out, leaving us with a or x or whatever you're using there. Over here, we have to do the inverse sine. So to enter that in your calculator, you'd have to, excuse me, you'd have to use the shift or the second key and then sine. So it would be second sine. For a second, for example, I might have second sine and then 0.338, close the parentheses. It'll give me 19.755 degrees. Yeah?
Would it also be
no, that's hyperbolic sine. That's slightly different. hyperbolic is something totally different we're not going to get into. And it deals with exponentials. And we don't want to get into it. What's that? There are other things that it can appear as. It can appear as inverse sine, like that. Or it sometimes appears as arc sine.
I mean, I should probably just go out and get it in our calculator.
Yeah, those are all just different notations for the sine -1. It can be INV sine or arc sine. On those calculators, a lot of times they don't even list it. There's just an inverse key somewhere. So you hit inverse and then sine.
Yeah, no, I'm just going to go out and get it.
Okay. So on your calculator, if I tell you the cosine of B equals 0.911, find B for me quick.
Found it.
What do you get? So it's secant cosine 0.911, 24.36 degrees. If I tell you that the tangent of angle D equals 2.7, can you find angle D for me? 69.68. Here's one for you. If I tell you the sine of angle F equals 1.4, can you find angle F? Why not? Yeah. Remember, in our unit circle, because our sine is a distance from the circle to that diameter, the sine can never be larger than the radius. I mean, the largest sine would be right here. That would be exactly equal to 1. So the sine is always going to be between -1 and +1. So if I tell you that the sine of angle A is 0.732, now it's possible because the sine is less than 1. It's between -1 and +1. So what do you get for A? 47.05. Is that the only angle for angle A? We look at this unit circle again. 0.732 is probably right about here is where that height is. That's the sine of 0.732. And that gave us this angle with the terminal side of 47.05 degrees. Is there any other spot on the unit circle that would have a sine of 0.732? Well, this would be negative down here, so it's got to be over here. Right here. That also has a sine of 0.732, and it's still positive. What's that angle going to be? Well, this angle here, to make, because of the geometry of it, this angle here would have to be 47.05. That's what we call a reference angle. What would the actual angle have to be here? 180 minus 47.05. It is the supplement of the angle. So that's going to be 132.95 degrees. What's that? A percent? What do you mean a percent? Oh. Is that better? Sorry. Yeah, that's a degrees, not percent. So whenever you do an inverse sine, keep in mind that there are actually two possible angles you could get. Now, when we're dealing with right triangles, when I do an inverse sine, would I ever get 132 degrees, really? Why not? Because, yeah, the angle sum of a triangle is 180, and in a right triangle, you already have one angle that's 90 degrees, so the other two have to add up to 90. But in a few weeks, we're going to look at obtuse triangles, or not obtuse, but oblique triangles that don't have right angles. And in those, it is possible to have an obtuse angle. So we'd have to very, very, very closely watch to make sure that when we do an inverse sine, that what we want is the angle the calculator gives, or is it really going to be the supplement of that angle? So if I tell you that the sine of angle B is 0.5, you do an inverse sine of 0.5, and you get what? $30 degrees? What other angle could it be? 150, the supplement of 30. Notice, I do sine of 30, I get 0.5. I do sine of 150, I get 0.5. They both have a sine of 0.5. So be aware that there are those two possible solutions. If I tell you that the cosine of D equals 0.839, D then has to equal what? 32.96 degrees. Is that the only possible answer for D? So here's my 32.96 degrees. 97. My cosine, remember, is this distance here. If I go over here that distance, is that the same cosine? No, this is negative over here. So this angle over here would not have the same cosine. But there is a spot that does have the same cosine. That's down here. That has the same cosine. This angle has to be 32.97. But the angle we want, of course, is this one. So here it would be 360 minus 32.97. Or 327.03 degrees. So for the cosine, the angle with the same cosine is 360 minus the angle that the calculator gives us. The good news here is this will never affect our triangles, because a triangle can never have an angle bigger than 180, can it? Because the angle sum of a triangle is 180. So when we're dealing with triangles, we don't have to worry about the fact that cosine has two different results when we do an inverse cosine. But for the sine, we do have to be careful, because that can pop up on us. So if I tell you the secant of angle G equals 3.4, can you find angle G? A little trickier, isn't it? Let's look at this. Let's say I have the equation 3x plus 2 equals, oh, whatever the heck we want to do, 14. If we look at how was this equation built, x was multiplied by 3. Come on. And then 2 was added to it, right? When we go to take it apart, we reverse that, don't we? We would subtract 2 and then divide by 3. Same type of thing happens here. If I calculate the secant of an angle, let's say I ask you to find the secant of 20 degrees. What you're going to put into your calculator is you're going to do the cosine of 20 degrees, and then you're going to do that reciprocal key, right? What's that give you for a number? What's that? 1.06. So cosine 20 close reciprocal. So I do get 1.064177 blah 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 blah. If I wanted to reverse this, if I knew that the secant of my angle equals 1.06. I apologize for the sloppy writing. My pen stopped working, so I'm going to have to shut down Word and restart it in just a second. If I want to find my angle, I have to reverse this process. What was the last thing that was done up here? The reciprocal, right? So I have to do the reciprocal first. And then I have to reverse the cosine, so it'd be the inverse cosine. Now the way we would punch this in our calculator is we do the secant to do the inverse cosine. We would punch in the 1.06. But now we want the reciprocal to happen before the inverse cosine, so we put the reciprocal inside the parentheses here. Does that make sense? So on my calculator, I'm going to do secant cosine, because I still want to do inverse cosine. Put in the 1.06, but I'm going to do the reciprocal before I close the parentheses. You see that? Now I hit equals, I get approximately my 20 degrees. With a little bit of round off here.
Where did the 20 come from?
I just made that up. Now we're going to go back here and do this one. To find the angle here, what G equals, I have to reverse this process, just like I did down here. So it's going to be secant cosine, because cosine goes with secant, of 3.4, but the reciprocal goes inside the parentheses. Gives me 72.90 degrees. Questions? Yeah? How do you do it? Here, let's scroll down. Okay. So let's have you guys try this one. Secant of angle B equals 5.1. Find angle B quick. See if you can make that work. So you're going to do the inverse cosine from the 5.1 with the reciprocal inside the parentheses. What do you get? 78.69 degrees. Let's double check you. Secant cosine, 5.1 reciprocal, close. That did not work with a cup. Let's try that again. Secant cosine, 5.1 reciprocal. 78.69 is correct. How many of you got that? Anybody have no clue how we got that? Still not getting it to work? So what if I told you that the cosecant of angle D is 2.7? Can you find angle D for me? Well, what trig function are we using here? Sine, so it's going to be the inverse sine, 2.7 reciprocal. Or on your calculator, Mike, it'd be 2.7, 1 over x, then secant sine. So secant sine, 2.7, come on. X negative 1, 21.74. How many of you got that to work? What if I tell you the cotangent of angle P is 0.032? Find angle P for me. So we're going to do inverse tangent of 0.032 reciprocal Second tangent 0.032.
That was definitely I did the inverse tangent.
Reciprocal. Come on, reciprocal. There it goes. 88.17. 1,790 might be a little large.
Just a little bit.
Just a little bit.
42.7. Getting closer.
In your textbook, page 725 and 726, exercise 33-5C and 33-5D. On both of those, if you do 1 through 23, the odds. On inverse trig functions. See if you can find the results. Not yet. You got 15 minutes to work, then we'll take a break.